Hi, in this lecture we are going to the details of the workings of Final Cut Pro software. But before getting into the details of the functions of the software, I want to give you a few concepts regarding the image sizes. You must have noticed that image sizes differ from one camera to the other. Some are squarish in nature, some are wideish. So what are they actually? Even NTSC, PAL, HD, all these have different image sizes. So let's get into the details of image sizes. Images, when recorded on NTSC, has got a pixel count of 720 by 480. So when we are working on the digital platform, we have 720 pixels by 480 pixels. This is NTSC. When we get into the PAL mode, the pixel count changes from 480 to 576, although 720 remains constant. So it is a little different from the NTSC image size. Further, we have intermediate HD resolutions. HD 720, which many cameras call 720p, has got a resolution of 1280 by 720. So 1280 pixels from left to right and 720 pixels from top to the bottom. Farther ahead, we have HD, or what we call full HD or true HD, which has 1920 pixels by 1080 pixels. This is how the HD resolution looks in terms of or in comparison to my NTSC or PAL resolutions. Above that, we have another resolution called 2K. 2K has 2048 pixels by 1556 pixels. You must have watched films on theaters. In theaters, what we see is a 2K image, or 2048 pixels by 1556 pixels. Video, as of now, is still restricted to HD resolution. If you want to shoot 2K, 4K or even higher, you have to get film cameras or digital film cameras which can shoot 2K resolution images. Now we are going to talk about the aspect ratio of an image. Aspect ratio is the ratio between the length and the breadth of the image. In cinemas, we have been watching films on a squarish screen for a long time until we got the widescreen images. If you watch films from the 30s and the 40s, you will see it's a little squarish in nature. But if you watch a film now, as in which is made in the year 2013 or 14, you will find that the film is far wider in nature. This is because the aspect ratio has changed. Now, let's start with the first aspect ratio, which was a little squarish in nature. It was called the 1.33:1 ratio. Later, that became a little wider and was called the cinemascope ratio, or the 1.85:1 ratio. It got even further and the ratio was struck at 2.35:1, which is the ratio that we usually see in theaters. So if you want the names, here are the names. 2.35:1 is called the anamorphic cinema ratio. 1.85:1 is called the cinemascope. 1.33:1 is what we see in television. And 1.375:1 is called the Academy ratio. Most of the films starting from the early 1900s till 1930, 40, 50 had this kind of a ratio. 1.77:1 is called the 16:9 ratio, which is the television wide. We'll discuss the television wide and the television 4:3 image in this lecture. What is 16:9 and 4:3? The image that we see on screen is a squarish kind of an image. This image is actually 4 units left to right and 3 units from top to the bottom. This is called a 4:3 image. Now, if I have an image like this, which is a little wider in nature, the ratio changes. The ratio here is 16 units from left to right and 9 units from top to the bottom. This is called the 16:9 aspect ratio. This is also called the video wide ratio. When you're editing, you often open a sequence which either has a 4:3 timeline or a 16:9 timeline. If I open a 4:3 screen, my squarish image, which is a 4:3 image, will happily fit in with no black or empty spaces around. So a 4:3 screen will get my 4:3 image comfortably. But what if I have a wide image here? There are two options. One is called a letterboxing image, where I fit in the wide image within the square screen. In this case, I will have black bands on the top and the bottom. This is called letterboxing of the image. I'm letterboxing the 16:9 image on a 4:3 screen. But there is one more option. I even can zoom the image so that I have the center part of the image fitting within the screen. In this case, I will have to sacrifice the left and the right part of the image. This is called pan scanning of the image. I am pan scanning the 16:9 image on a 4:3 screen. If you look carefully on your DVD player's menu, you will see there are two options. One is LB, which is letterboxing, and one is PS or pan scanning option. You switch between letterboxing and pan scanning, and this is the result that you get on a 4:3 television. Now let's get into the 16:9 platform, where I have my screen as 16:9. All latest television models, LCD, LED, plasma TVs are widescreen. That is, it's 16:9. So I can fit my 16:9 image happily onto that television, where I won't have any black bands left or right, top or bottom. So a 16:9 screen will fit in the entire 16:9 image. This is called 16:9 anamorphic projection. But what will happen to the image which is shot 4:3? 4:3 image, when fits into a 16:9 screen, leaves two black bands on the left and the right. This is called pillar boxed projection. When you are watching a normal telecast on a LCD screen or a LED TV at your home, you often see there is a black band on the left and the right if you are actually projecting the image in its perfect ratio. In most cases, what we do is we stretch the image to fit the screen. In that case, the images stretch from left to right. That is not right. We should watch the film with the black bands on the left and the right, and which is called pillar box projection. Now, let's go back to FCP and see how a wide image and a squarish image looks on the screen. Here, we had a clip. This clip is squarish in nature. That is, this will be a 4:3 image. But look carefully, the timeline that I have here is a widescreen timeline. That is, this is a 16:9 timeline. So when I bring in the 4:3 image on a 16:9 timeline, this is what happens. Look carefully. I have a black band here, and the image is ending here. So this is called pillar boxed image. Now let's open a new sequence which is 4:3 in nature. I put in a 4:3 image and my timeline is now 4:3. See, I do not have any black bands on the left or on the right. This is a 4:3 timeline. Now if I want an image which is 16:9 in nature, this is a 16:9 image. So I take a selection of the 16:9 image and I put it on a 4:3 timeline. See, now I have a black band here and I have a black band here because my 4:3 timeline is trying to fit in the 16:9 image. That is why I am getting something called a letterboxed image here. So if I play this together, I will have this full screen image followed by a letterboxed image. Now, as I discussed, if I want to do a pan scanning of this image, I can increase the size of this image by zooming in. But how do I do it? There is a motion tab on the source monitor. This is the motion tab. This is the motion tab. What is the function of this motion tab? If I want to work on this particular clip on the timeline, what I do is I double click on this clip. I do a double click and this timeline clip opens on my source monitor. Look carefully, I have little dots here. This means that this is a selection of the clip from the timeline and this is not the actual rush. Once I have this, I will open the motion tab. The motion tab has got a few manipulators in terms of the scale, the angle of the image and so on. Let's do it one by one. First is the scale. The scale here is showing 40 because the image that I had here is a 4:3 standard definition image. The image that I have as my second shot is an HD image which is far larger in size. So that to fit that image onto that timeline, I need to squeeze that image and it has automatically come to 40. Now if I want to do a pan scanning of this image, I will start increasing the size. Okay, till I cover the black bands on the top and the bottom. Now I have a squarish image. I have done a pan scan and there won't be any black bands. But obviously I'm going to lose the left and the right part of the wide image. Let's see the other functions on the motion tab. One is called the rotation. Let's bring this back to 40. The rotation manipulator is the angle at which this is placed. If I want to manipulate the rotation, I can do it by changing the angle. Say I want it here. So if I play it back, it will be a tilted image. Next is the crop tool. In the crop tool, I can crop the image as you often do in case of Photoshop or other image manipulators, where you can mask the image either from left or from right or from top or from the bottom. So if I want to hide this image, I do a crop to the left, crop to the right, from the top if I want to, and from the bottom if I need it. There is one more slider which is called the edge feather. So if I want to feather the edges and I do not want a sharp line like this, I can even add a edge feather where my edges would be a little smoother. Next is the distort tool. If I want to distort, I can distort the image the way I want it. These are numbers here, but it's a little difficult to manipulate these numbers and know how to distort this image. For this, I have another tool which is called the distort tool. On the keyboard, press D. If you press D on the tool palette, look here on the tool palette, you will get the distort tool. D is the shortcut for distort tool. Once you have it, I can manipulate the image here, but for that I need to activate another thing. Come to this section of the record window and enable the overlays. Next, click here and enable the image and wireframe. The overlays will give you an idea about the image size. This is the area that is called the title safe, which is the part that definitely is going to come within your television screen. This is the area which comes within the television screen, but it's almost at the edges. Beyond this line, this is the area which is never going to show on your television screen during broadcast. So make sure none of the elements are beyond this line. Now I select this image and my wireframe is active. With the distort tool, I can select any corner and distort the image if I at all need to do it. Again, I select the distort tool, I come to the corner and the arrow changes to the distort tool here, and I drag it according to what I need. See, the numbers here also change automatically. Obviously, it's very difficult for you to say that this kind of an image will be given by these numbers. So it's always better to go with the tool rather than these numbers. Another distort function is the aspect ratio distort, which is it will change the aspect ratio whichever way you want it. The next function is called the opacity tool. The opacity tool is basically the opacity of the image. That is, when at 0, I only see black and the image is absolutely transparent, and when 100, I can absolutely see the image. Anything behind that image is not visible. So from 100 to 0, you can have any number according to your requirement. So we'll see superimposition when we are going to talk about effects. During superimposition, if you have this particular clip set at 50, you will be able to see the image behind it. Opacity can also be handled with keyframes. Say for example, this particular clip. I can activate the rubber band with this particular function here. If I activate this, there's a black line which comes at the top of the clip. I've told you what pen tool is. Select the pen tool or press P or select the pen tool from the tool palette and add a keyframe here and add a keyframe here. Now this is nothing but the opacity handle. Let's also open the opacity tab on the motion tab. Now if I manipulate, that is, if I drag this keyframe down, this means that my opacity is 100 here and it will gradually come down to 0 at this point, and this will give me the effect of a fade out. The next tab is called the drop shadow option. We'll talk about drop shadow when we talk about title tools. Now we are going to talk about timeline settings. When you open a timeline and you open an image, obviously the timeline settings has to match with the clip. If you are not taking clips which match the timeline settings, then every time you have to render and watch the film. So in FCP7 there is a beautiful feature, that is, if you just drag your clip on the timeline for the first time, you will get an error message which says that for best performances you need to change the timeline settings to the settings of your clip. If you want to accept, then do it. If you want to say no, you can always say no. In this case, if I click on yes, this changes to the settings of the timeline. Now let's get to the settings of the timeline. This is sequence 2. So if I go to the settings of this particular sequence, I will get the details of this timeline. Here we see the frame size is 1920 by 1080, which means that this is an HD image. The pixel aspect ratio is square and the field dominance is set to none. Let's see the options in field dominance. We have an upper field and we have a lower field. what are upper field and lower field options? You must have heard about video being interlaced and progressive. In some cases you see you have 1080i written. In some other cases you see 1080p. What does I and P stand for? I stands for interlaced scanning and P stands for progressive. Let me give you an example. See this image. Here the left side image, which is marked as field 1, has got half of the image. Half of the image is represented in field 2. If I combine these two images, I will get the frame, which is frame 1 in this case. This is the concept of interlaced scanning, where I store images in terms of fields. Combining two fields, I get a frame, which is my complete image. All television broadcasts are done with interlaced scanning. That is, I transmit 50 fields per second in case of PAL transmission. In case of NTSC, this would be 60 fields per second. When I say it's an even field signal, I mean that I start with field 2 and field 1 comes later. When I say it's an odd field signal, I mean that field 1 comes first and I end with field 2, which ultimately gives me the first frame. Now let's go back to the Final Cut software. In this case, I do not have field dominance, which means that I am doing a progressive scanning. Here, the concept of field does not arise because the entire image comes at one go. So I have field 1 and field 2 coming together as frame 1. This is called progressive scanning. Let's go to the settings. The editing time base is set at 25. I have other options. In NTSC, I have 29.97 or 30 FPS. When I'm editing films, it is usually at 24. I have 24 frames per second. In the compression settings, I have Apple ProRes 422. As we have discussed that we can have Apple ProRes as 4x4 or 422HQ or 422 proxy. Whichever I choose, I will have to make sure that this is set at the same codec settings. This is audio settings. We'll deal with audio settings later. So once the sequence settings is alright, I click on OK. On this timeline, since I'm working with HD image and I also have opened an HD timeline, if I somehow need another codec material and I want to place it on the same timeline, let's see what happens. Say for example, I have a 4:3 SD image on this. I drag and drop that image here and I immediately have a pillar boxing happening. More importantly, I can see a green line coming here. This means that the timeline settings are not matching, and to view this clip, I need to do a render. When I see a green line here, it means that the software can do a real-time rendering. That's all in this part of the lecture. In the next lecture, we will deal with effects and more on FCP.